It's never aliens, until it is. The closest star to our own, Proxima Centauri, is too dim to see from Earth with the naked eye, but is nonetheless a cosmic stone's throw away at just 4.2 light-years. On December 18th, news of the mysterious signal leaked in the British newspaper The Guardian. The signal was discovered this fall in archived data collected the previous year. But what was that? Want to know more? So stay tuned to the future space because we are going to reveal the secret. It seems to originate from the direction of our neighboring star and cannot yet be dismissed as Earth-based interference, raising the very remote possibility that it is a transmission from some form of advanced ETI, a so-called technosignature. Researchers who made the discovery have since spoken to Scientific American, where they emphasize that more work needs to be done before the discovery can be fully explored, but also acknowledge that the interest is warranted. It has some particular properties that caused it to pass many of our checks, and we cannot yet explain it, says Andrew Simeon of Berkeley. Most unusually, it only uses a small portion of the radio spectrum, specifically 982 MHz, a frequency range typically devoid of transmissions from artificial satellites and spacecraft. According to Simeon, there is no other natural way to compress electromagnetic energy into a single bin in frequency like this one. He suggests that the highly concentrated radio waves might have a natural explanation in some as-yet unknown exotic quirk of plasma physics. However, at this time, technology is the only known source. Breakthrough Listen, led by Simeon and funded by tech tycoon Yuri Milner as part of Milner's breakthrough initiatives, made the discovery. This multi-year project, announced in 2015 with the help of space science luminaries like Stephen Hawking, aims to purchase observing time on radio telescopes around the world to look for signs of technological civilizations in the cosmos. The term search for extraterrestrial intelligence is commonly used to refer to this endeavor, SETI. Despite more than half a century of low-key but consistent SETI efforts, no conclusive evidence of extraterrestrial intelligence has been uncovered. Any possible signals have been most always dismissed as noise from Earth-orbiting satellites or other forms of human-caused interference. If you see such a signal and it's not coming from the surface of Earth, you know you have detected extraterrestrial technology, says Jason Wright, a Penn State University in Pennsylvania astronomer who specializes in searching for extraterrestrial intelligence. Unfortunately, humans have launched a great deal of space-based equipment. On April 29, 2019, scientists from Breakthrough Listen began collecting data that would eventually reveal the intriguing signal, marking the beginning of the story of this latest SETI spectacle. In order to learn how such flares might affect Proxima Centauri's planets, a team has been using Australia's Parkes Radio Telescope to observe the red dwarf star. At the very least, two planets exist in this system. The first, which was given the name Proxima b after its discovery in 2016, is in an orbit that lasts for 11 days and is roughly 1.2 times the size of Earth. If Proxima Centauri's intense stellar flares haven't sputtered away a world's atmosphere, then Proxima b is located in the star's habitable zone, a loosely defined sector in which liquid water could exist on a rocky planet's surface. In 2019, the 7 Earth mass planet Proxima c was found in a frigid 5.2-year orbit. The astronomers had observed the star with Parkes for 26 hours as part of their stellar flare study, and they had flagged the resulting data for a later look to seek out any candidate SETI signals, as is standard procedure within the Breakthrough Listen project. Hillsdale College undergraduate and intern in Simeon's SETI program at Berkeley, Shane Smith, was tasked with the responsibility. Smith started looking through the data in June, but it wasn't until late October that he discovered the unusual narrow-band emission, sharp at 982.002 MHz, and hiding in plain sight in the Proxima Centauri observations. From that point on, developments moved rapidly and with good cause. Penn State University's Sophia Sheikh, who led the subsequent analysis of the signal for Breakthrough Listen and is the lead author on an upcoming paper detailing that work, calls it the most exciting signal that we've found in the Breakthrough Listen project, because we haven't had a signal jump through this many of our filters before. The paper detailing that work is scheduled for publication in early 2021. The signal was soon given a more official moniker by the team, BLC-1, which stands for Breakthrough Listen Candidate 1. A signal must pass through a battery of simple automated tests to eliminate obvious terrestrial interference before it piques the interest of any SETI researcher. However, hundreds of applicants typically make it past this stage and are singled out for further scrutiny. From there, almost all of them will be disregarded as a mirage or error, perhaps an excess of static, for example, that tricked the winnowing algorithm, and thus eliminated from consideration as a transmission from communicative aliens. Until this one, Sheikh says. When Sheikh and her team looked back at the 2019 data, they saw that the telescope had scanned Proxima multiple times for 30 minutes over the course of a week. To ensure that any potential signal is coming from the target and not, say, someone microwaving their lunch in the observatory cafeteria, Breakthrough Listen employs a technique known as nodding, in which the telescope will spend a period of time looking at a target and then an equivalent period looking elsewhere in the sky. According to Sheikh, in 5 of the 30-minute observations over about 3 hours, we see this thing come back, suggesting that the signal did indeed originate from Proxima Centauri or another deep space source in that region of the sky. In that case, it would seem that the investigation is complete. Even though an explanation with a natural cosmic source seems improbable, it is not yet out of the question. If anything, the possibility of an unnatural explanation involving aliens is thought to be even less likely. Consequently, every Breakthrough Listen team member quoted in this article insists that the likelihood of this not being terrestrial interference is extremely low. Pete Warden, director of the Breakthrough Initiative, says, "The most likely thing is that it's some human cause. When I say most likely, I mean 99.9% sure." That kind of reasonable skepticism permeates the entire organization. When Milner and Hawking launched Breakthrough Listen in 2015, it was agreed that the most rigorous scientific approach would be used to evaluate all candidate signals. As a result of the increased scrutiny, Milner and presumably all of the SETI researchers his funding supports expect BLC-1 to wither and die. However, there is always the chance that it won't. To rule out any other possible causes, additional testing will take months, and BLC-1 itself, despite its Proxima Centauri origin story, does not quite fit the profile of a technology from that star system. First, there is no evidence of modulation, which would be changes to the signal's properties that would allow it to carry information. Essentially, there's only one note to BLC-1, as Simeon puts it. At this time, we can find no other distinguishable features. Second, the signal drifts or appears to change frequency very slightly. This could be caused by Earth's rotation or by the motion of an extraterrestrial source, like a transmitter on the surface of one of Proxima Centauri's worlds. A signal from the planet orbiting the Sun's nearest stellar neighbor should drift in the opposite direction, but this is not the case. We would anticipate a decreasing signal frequency like a trombone, Sheikh says. Instead, the frequency goes up like a slide whistle. The signal has not been detected in subsequent Parkes observations, which is problematic because we need another observation to verify that BLC-1 is a genuine techno-signature. If it's an ETI, it must eventually be replicable, because it's unlikely it would be a one-off, says Shami Chatterjee, a radio astronomer from Cornell University in New York. Hell yeah, if another group at another observatory can recover the same signal. Even though I'm willing to wager that they won't, I hope I'm proven wrong. Sheikh likens it to the so-called WOW signal discovered in 1977, which some believe to be of extraterrestrial origin, and it remains one of the most intriguing signals found by Breakthrough Listen or any SETI program to date. We should have a definitive answer in a month or two. Still, at least for the time being, it can't be aliens, right? What do you think? Do let us know in the comments section below, and if you like this video, do make sure to subscribe to our channel for more amazing content like this.